Hello everyone, and today I'm going to share with you some techniques and methods that you can use and apply in Olympiad geometry problems. I hope you got excited, so let's start. So let's move on to my first problem, where in this problem we've got a circle, and we know that AD is diameter of the circle, and we also get a point that is on the diameter, and we know that AX equals 10 and XG equals 15. And B and C are the 2 points on the circle, and the distance between these 2 points equals 7. And we should calculate the square of BCX, of the triangle BCX. At first, let's continue the line BX before it intersects with the circle at the point Y. After that, let's draw CY. Let's just say that the angle BYC equals alpha. Just because the points are completely symmetrical by the diameter AD, XCY also equals alpha. This means that the angle BXC equals double alpha. And I would like to quickly write down the law of sines, which states that 7 divided by sine alpha equals double radius, or which in our case equals 25. After that, using some basic algebra, we can state that sine alpha equals 7 divided by 25, and using the Pythagorean trigonometric identity, we can say that cosine alpha equals 24 divided by 25. After that, let's use the formula of sine of the double angle and say that multiplied by cosine alpha and multiplied by 2 would be equal 346 divided by 7, so 625. After that, let's write down the formula of the square of the triangle XBC using the sine. We can say that BX times CX times sine of the double alpha divided by 2 equals the square of the triangle XBC. However, by now we can't say that we know the product of BX and CX. However, using the fact that the points C and Y are completely symmetrical based on the by diameter, and using the fact that if 2 chords of a circle intersect, then the product of segments of one chord equals the product of segments of another chord, which basically means that if the points are symmetrical, and they are symmetrical, and it means that xy equals cy, then we know the product of multiplication of bx and xy, which means that we know the product of bx and cx, which is enough for our for finding the square of the triangle XBC, which would be equal 150 multiplied by 346 divided by 625 divided by 2, which equals 40.32. In the second problem, we are given the right triangle, where we know that the hypotenuse of the right triangle equals 28 and the square of this triangle equals 98. And we should find the angle between the hypotenuse and the side A. First of all, let's calculate the cosine of the angle, which would be equal A divided by 28. After that, let's use the formula of the square of the triangle using the sine, and say that the square of the triangle equals 28 multiplied by A multiplied by sine x divided by 2. And after that, let's say that the side A equals 28 multiplied by cosine of the angle that we're looking for. Applying this to the formula of the square of the triangle, we get that square of the triangle equals 14 times 14 times 2 times cosine x times sine x, which leads us to the equation that square of the triangle, which equals 98, divided by 14 times 14 would be equal 2 multiplied by cosine x multiplied by sine x, which is actually the formula of the sine of the double angle. And it leads us to the fact that 98 divided by 14 times 14 equals sine of 2x, and which means that 1 divided by 2 equals sine of 2x, and we know that sine of 30 degrees equals 1 divided by 2, which means that 2x equals 30 degrees and x equals 15. And the last problem that we are going to solve is this. We are given the right triangle ABC, where we know that the angle CAD equals 45 degrees and DC equals 10. And we need to find the value of the distance between the points A and D. First of all, let's just say that BD equals Y. After that, let's apply trigonometry and say that we know the tangents of Y, of alpha. And let's say that tangents alpha equals y divided by 6. After that, let's have a look at the angle y plus 45 degrees. We can say that tangents of this angle equals y plus 10 divided by 6. Well, after that, let's use the fact that for every angle, it's correct that tangents 45 degrees plus this angle equals 1 plus tangents of this angle divided by 1 minus tangents of this angle. So basically, we are going to get the following equation, that alpha plus 45 degrees, which is 10 plus y divided by 6, would be equal 1 plus y divided by 6. And this whole thing will be divided by 1 minus divided by 6. That using some basic algebra, we got that plus y equals divided by 7 by 6 minus y would be equal plus y, and this whole thing will be divided by 6. After multiplying the parts, we get that after multiplying the parts of the fraction, of the proportion, we get that 6 multiplied by 6 plus y is equal to 6 minus y multiplied by 10 plus 1, which leads us to the following equation, that y squared plus 10y minus 24 is equal to 0, and the roots of this equation would be y equals 2 and y equals minus 12, but y is always positive, so it means that we can omit this answer. After that, using the Pythagorean theorem, we can find that x squared equals 6 squared plus y squared, which means that x equals to 36 plus 4, which means that x equals to 2 multiplied by the root of 10. And here is our answer. We use some facts from geometry that tangents of x plus 45 equals 1 plus tangent x divided by 1 minus tangent x. And also we use some basic calculations. So these were the methods that I wanted to share with you, and I really hope you apply them in your future Olympiads that you're going to participate. And thank you for your attention.